Today, we're going to be talking about how black holes form, specifically stellar mass black holes. To explain the formation of black holes, we first need to learn about the lifetime of a star. Stars are born when large gas clouds collapse. These gas clouds fragment into many different masses, creating stars of various lifetimes. First, let's look at a low-mass star. Think about stars that are about 0.1 times the mass of the Sun. They are less hot and have longer lifetimes. They burn slowly through their fuel between 10 to 100 billion years, which is longer than the age of the universe. Then we have high-mass stars. Think of them as about 10 times the mass of the Sun. They're very bright and very hot. They also have shorter lifetimes, as they burn through fuel quickly, between 10 to 100 million years. But what does it really mean for a star to burn through its fuel? Well, stars are fueled by the fusion of hydrogen atoms to create helium and energy. This process is called nuclear fusion. While the star is still burning, gravity pushes inward towards the center of the star, while the pressure from nuclear fusion pushes outward, creating an equilibrium. However, when the star eventually runs out of hydrogen atoms to fuse, gravity wins, and the star begins to collapse inwards. As the star collapses, the outer atmosphere of the star drifts away, while an inner core is left. This is where things get interesting. Remember how we mentioned that stars have different masses? If the inner core of the star ends up to be less than 1.4 times the mass of the Sun, then the core of the star doesn't entirely vanish. Electrons left in the core of the star repel each other, creating a force outwards which counteracts gravity. This creates a white dwarf. If the inner core of the star is greater than 1.4 times the mass of the Sun, the star's life ends violently. It essentially explodes into something called a supernova. If the inner core of the star is between 1.4 to 3 times the mass of the Sun, pressure of the nucleus can counteract some effects of gravity, creating a neutron star. However, if the inner core is greater than 3 times the mass of the Sun, nothing can save the core of the star from the strength of gravity, and everything collapses, creating a black hole.